Alright, this is the fifth and final lecture for Text Unit 3. The topic of this lecture is limiting and excess reactants. The best way to illustrate this or discuss this is to begin with an example. Consider the following reaction in which 6 moles of lithium reacts with a mole of nitrogen to make 2 moles of a compound you should be able to identify, lithium nitride. Suppose 51 grams of lithium reacts with 39 grams of nitrogen. You can ask the question, how many grams of product are made? Now note the unusual thing about this problem compared to problems we've done is that we have grams or amounts of both of the reactants. Where does one start with a problem like this? This is a limiting reactant problem. You can identify a limiting reactant problem from the fact that you have amounts of both reactants available. As the reaction progresses, one of these reactants, lithium or nitrogen, will eventually running out, leaving some of the other left over. The one that runs out first determines the amount of product made and is the limiting reactant. The other is called the excess reactant, or just said to be excess. And you've heard this term before in problems you've worked. In other words, previous problems have told you what the excess reactant is. You've been told that there's enough to react with the other reactant, for example. Here, you are not told which reactant is excess. It's important to determine which is the limiting reactant, which is the excess reactant, because the limiting reactant determines the amount of product made. What I present here and what the text presents is the fractions method for limiting reactants. This may not be the method you've been taught in high school or previous courses you've taken, but this method, or previous courses you've taken, but this method is fast. This method always works. And here's what you do. Convert grams of reactants, each reactant, to moles, then divide moles of each reactant by the stoichiometric coefficient to find the fraction. The smallest fraction tells you the limiting reactant. I'll use the problem I just posed to illustrate this approach. Again, the problem is lithium reacts with nitrogen to make lithium nitride. We have 51 grams of lithium and 39 grams of nitrogen available. Which of these two will be the limiting reactant? We're going to calculate the fraction for each. All right, the fraction for lithium is found first by taking 51 grams and converting to moles. There are 7.4 moles of lithium. Then dividing by the stoichiometric coefficient from the balanced equation, which is 6. Since I could read this equation, 6 moles of lithium react with 1 mole of nitrogen to make 2 moles of lithium nitride. I can assume that this 6 has units of moles for this fraction calculation. 7.4 moles over 6 moles cancels units of moles, and the fraction for lithium is 1.2. All right, make a note. 7.4 moles of lithium. Fraction is 1.2. All right, now here is the fractions calculation for nitrogen. Start with 39 grams, use the molar mass, convert to moles. There are 1.4 moles of nitrogen after converting grams to moles by dividing by the molar mass. Now because the stoichiometric coefficient of nitrogen is 1, we divide 1.4 moles by 1 mole and obtain a fraction of 1.4. Right, now compare fractions. The fraction for lithium is 1.2. The fraction for nitrogen is 1.4. Since the fraction for lithium is smaller, lithium is the limiting reactant. Nitrogen is in excess. Now be careful. The thing to compare here is the fractions, not the moles. There are actually more moles of lithium than nitrogen. But the fraction for lithium is smaller, and lithium is therefore the limiting reactant. The limiting reactant is the starting point for all the stoichiometry problems involving this reaction. We know moles of the limiting reactant, so we can use that as our starting point to determine how much product will be made. There were 7.4 moles of lithium, which we convert to moles of lithium nitride using the balanced equation. 2 moles of lithium over 6 nitride over 6 moles of lithium. Moles of lithium cancel. And then we multiply by 34.830 grams, the molar mass of lithium nitride, over moles of lithium nitride. Cancel moles of lithium nitride. And the solution to the problem is 86 grams. Again, we start with moles of the limiting reactant, which we already knew because we calculated it, and calculate grams of product. Now, a typical question asked in limiting reactant problems at this point is to find the amount of excess reactant, which you'll remember is nitrogen, which is left over. Nitrogen is the excess reactant. We know that because from our previous calculation. Now we can calculate the amount of nitrogen reactant. Now again, we know the limiting reactant, that is the starting point for all stoichiometric calculations. So we start with 7.4 moles of lithium. We can convert that to moles of nitrogen using a conversion factor from the balanced chemical equation, 1 mole of nitrogen over 6 moles of lithium, and then convert to grams of nitrogen by multiplying by the molar mass of nitrogen over moles of nitrogen. The result is 34 grams of nitrogen. Now again, what this calculation tells us, starting from moles of the limiting reactant, is how many grams of nitrogen react. To determine the amount left over, take the amount that we started with, 39 grams, and subtract 34 grams. There are 5 grams of nitrogen left over. Here is one for you to attempt. Hydrogen cyanide is used in the production of cyanamide fertilizers. It is produced by the following reaction of CH4, NH3, and elemental oxygen. Now, a typical question an industrial chemist might face is how much hydrogen cyanide in kilograms can be produced starting with 100 kilograms of each of the reactants. Now, why don't you attempt this problem? Take molar masses only to the 10th place to make it quick. And remember that 100 kilograms is 1 times 10 to the 5th grams. So you have 10 to the 5th grams of each of the 3 reactants. All right, now again, attempt this problem taking molar masses to the 10th place and using the fractions method before you move on to look at the solution. Right, now here is the solution. We have 3 reactants. Here are the molar masses of each to the 10th place. We can calculate number of moles of each reactant. That's shown here for CH4, then for NH3, and then for O2. And we find moles of each. 6.3 times 10 to the third, 5.9 times 10 to the third moles of NH3, and 3.1 times 10 to the third moles of O2. Okay, those numbers are presented again down here. 6.3 times 10 to the third moles CH3, 5.9 times 10 to the third moles NH3, 3.1 times 10 to the 3 moles of O2. Here we have coefficients from the balanced chemical equation. Divide moles by coefficients to determine the fractions. Oxygen, O2, has the smallest fraction after this calculation, and therefore oxygen is the limiting reactant. The limiting reactant is the starting point for all stoichiometry problems. We can start with 1.0 times 10 to the 3 moles of oxygen, convert to moles of product using the balanced chemical equation, 2 moles HCN over 3 moles O2, and convert to grams of HCN using the molar mass, or 27.0 grams HCN over 1 mole HCN is 1.8 times 10 to the 4th grams of HCN. And the problem actually asks for kilograms, not grams, so you would have to convert this to 18 kilograms to have the correct answer. Alright, this concludes the 5th and final lecture to accompany Unit 3.